For the last exercise of this chapter, we're going to demonstrate how you can simulate shuffling a deck of cards using a two-dimensional array. We'll start out by writing the methods, and then we'll go back and write the top-level program. First thing we need is a method to initialize the deck of cards. So what we're going to do is we'll pass in a parameter of a two-dimensional array. In this case, we can use literals for the number of rows and columns, since for a deck of cards it will always be the same, 4 rows and 13 columns, to represent the 4 suits and the 13 denominations in each suit. So our loop will run 4 rows, 13 columns, as I just said. And what we'll do is we'll initialize each position in the array to a 0. That will represent a card that has not been assigned a denomination or a suit yet. As we go through the shuffling process, that will take a random row and column and then assign a card number to it. So it's almost like we're taking a position and then assigning a card number to it, rather than taking a card number and assigning a suit and denomination to it. It's kind of like we're doing it backwards. So the initDeck method is simply to initialize the deck to all zeros, the two-dimensional array. Then we also need a displayDeck method to look at our result, or just to look at the deck anytime we want to view it. It will be also fairly simple. Just nested for loops that display the card information. And that's just a console write with the array element and a space. And then a console write line when we're finished with one row or suit to take us to the next suit or row. So those are the two simple methods. Now all of the really hard work will come in this third method, which we're going to name shuffleDeck. It also will take a two-dimensional array as its argument or parameter. So we're going to start off with 2 variables for a row and column. Then we're going to create a random number generator. Then we begin a loop. This loop is going to represent each card in the deck. So we're going to go from 0 to 51 to represent the 52 cards. First thing we do is we generate a suit, and they can be in any order you want. We are not representing the order here. You can start with hearts, diamonds, then clubs and spades, or you can start the other way around. It doesn't matter. That's not the point here. Then we generate a random number to represent a denomination. And again, there is no necessary stating of the rank from low to high. So ace could be low or ace could be high. Of course, we know that the other cards are already in their order. And then a program that used this deck would have to make that determination. So then, after we've generated a random number for the row and the column, then we check to see if that position is open. In other words, is its value equal to 0? If so, then it can be assigned the card value. So for example, if we hit row 2 and column 2 and it's equal to 0, then that's going to be the first card in the deck. It just depends on what the random number generator generates. If it's not equal to 0, then we write another loop, a while loop, that looks for a 0. A cell or a row column position that's 0. And to do that, we generate random numbers again. And then when we get to a row column that is equal to 0, we assign it that card value. And that should take us through the program. So once again, there's the shuffleDeck method. Now we're ready to write our top level program. So the first thing we're going to do is create a couple of constants. And we're going to initialize our two-dimensional array that stores the deck. We'll call it deck with rows and calls. Then we call the initDeck method with deck as the argument. Then we'll display the deck just to verify that it is all initialized to zeros. Then we'll call a console write line right here. Then we'll call shuffleDeck to shuffle the deck. And then we'll display the deck again. And then we have a console read key to hold our screen open. So that's it. Again, let me emphasize how using methods makes your main program so clean and easy to read. And that's one of the reasons we write methods to start with, is to make the main program easy to read so that we can ignore details if we don't care about them. Then if we care about them, we simply scroll down to the method definitions and take a look. All right, so let's run the program. There's our initialized to 0 deck, and then here's our deck with the 52 cards assigned. So row 0, column 0 is card 1. So that can be a 2 of hearts, or however you want to start with the denominations and suits, and that would be how it works. Let's do it one more time, just to see that we'll get a different deck every time we shuffle. And then let's do it a third time, just to verify. So this is a very good example of how to use a data structure, such as a two-dimensional array, in a quote-unquote real-world program, or in a real-world situation, shuffling a deck of cards. And with that, we've finished this chapter on arrays, and we're ready to move to the next chapter where we talk about different alternative control flow structures you can use in C#.